Assalamu alaikum, sir. Today we will be talking about sensors, and the first sensor that I have took for this video is thermistor sensor. The thermistor sensor temperature module uses an NTC thermistor to measure temperature and provides an analog output. Package includes thermistor temperature sensor module. Key features of thermistor temperature sensor module is it uses NTC thermistor. Its range of measurement is from -55 to 125 Celsius. It provides analog output of the reading and 3.3 and 5 volt operation. It consumed 5 volt or 3.3 volt. This module utilizes an NTC thermistor for measuring temperature. The output is normally input into an analog port on a UC where it can be read and temperature calculated. Thermistors are essentially resistors whose resistance value changes with changes in temperature. NTC stands for negative temperature coefficient, which means that the sensor resistance will decrease as temperature increases. The thermistor is in series with an 10K resistor which creates a voltage divider. As the temperature warms up, the resistance lowers and the analog output increases towards VCC. The sensor is capable of reading temperature in the range of -55 to +125 Celsius with an accuracy of ±0.5 Celsius. Module connection. The module has a 3-pin header on the assembly for connection. The pin is connected to ground, the center pin is connected to VCC, and the S pin is connected to an analog input pin on the UC. If the output goes in the wrong direction, resistance goes up. As temperature goes up, reverse the power and ground pins. 1 cos 3 header. The symbol is that ground center pin is 5 volt and S is signal output connects to analog input on UC. Evolution result. This is commonly used module for basic temperature measurement. Once up and running with a UC, it is easy to test the module by using the fingers or warm the sensor and monitor the output. Using device requires some math, convert voltage output to temperature. We use the beta method for temperature calculation, but there are several different formulas that can be used. To use this program, you will need several values of measurement to plug into program. Balance resistor, measure the actual value of the balance resistor that is on the module. It is normally 10K resistor. Typically 123.0 if using a standard 10-bit analog input. For the beta calculator, the current room temperature measure as accurate as you can. You will need to use an online conversion tool. Resistor room temperature. This is the resistor value of the NTC thermistor on the module measured at the room temperature. Be sure not to accidentally heat the thermistor with your fingers while taking the measurement. Thank you. So after evolution result, we have here code for Arduino to use thermistor sensor. This is the code, and after that we have some technical specification for this thermistor. So this is all. Hello again, sir. Sir, the second sensor that I took for the video is IR proximity sensor. So it is a sensor that is a multipurpose infrared sensor, is an add-on or for your line follower robot and obstacle avoiding robot that gives your robot the ability to detect lines or nearby objects. The sensor works by detecting reflected light coming from its own infrared LED. By measuring the amount of reflected infrared light, it can detect light or dark lines or even objects directly in front of it. And on onboard red LED is used to indicate the presence of an object or detect line. Sensing range is adjustable with inbuilt variable resistor. The sensor has a 3-pin header which connects to the microcontroller board or Arduino board via female to female or male or female to male jumper wires. A mounting hole for easily connect one or more sensor to the front or back of your robot chassis. The feature that it includes are 5 volt DC operating voltage, input and output pins are 5 volt and 3.3 volt complement. Range is up to 20 centimeter. Adjustable sensing range, built-in ambient light sensor, 20 milliwatt milliampere supply current, and mounting hole. So specifications are that its size, length is 50, breadth is 20, and height is 10 millimeter. The hole size is almost around 2.5 millimeter. The schematic view is like this, sir. As you can see that IR LED is like connected with the resistor, then ground, and 5 volt is applied on it. Then photodiode then resistors, ground, and in the end that we have JB1 5 volt ground and output is coming out of it. So the hardware details is like this, that we have a variable resistor setup which we can change from 0 to 20 centimeter. We have three pins. One is 5 volt at the most left, then in the center we have ground pin, and on the right we have output. And then in the front we have one IR transmitter, one IR receiver, and the surface on which it reflected rays. So the next thing is interference to Arduino. Now let's we build simple object counter using IR proximity sensor that count the number of object. Connect Silicon Techno Labs IR proximity sensor to your Arduino board as shown in below image. So the 5 volt is connected to the 5 volt, ground is connected to the ground. These ground and 5 volt on Arduino is on power pins, and then the output is connected with the digital output that is on the second digital pins and the second one. So this is the interface to Arduino, and Arduino simple code is given like this. So thank Hello again, sir. The third sensor that I used is ACS712 AC/DC current sensor. It is a fully integrated half-effect based linear current sensor with 2.1 kilowatt RMS voltage isolation and an integrated low resistance current conductor. Technically terms aside, it's simply put forth as a current sensor that uses its conductor to calculate and measure the amount of current applied. The features of ACS 712 include 80 kHz bandwidth, 66 to 185 millivolt per ampere output sensitivity, low noise analog signal path, device bandwidth is set via the new filter pin, 1.2 milliohm internal conductor resistance, total output error of 1.5% at TA is equal to 25 Celsius, stable output offset voltage, near zero magnetic hysteresis. How does the ACS 712 current sensor work? So now that we have an idea of what the ACS is capable of, we'll look at its working principle. When it comes to how a current sensor works, it can either be done through direct or indirect sensing. For current sensor that work by direct sensing, Ohm's law is being applied to measure the drop in voltage when following current is detected. Current flows through the on-board Hall sensor circuit in its IC. The Hall effect sensor detects the incoming current through its magnetic field generation. Once detected, the Hall effect sensor generates a voltage proportional to its magnetic field. That's then used to measure the amount of current. Current sensors applications. We have established a general idea of what current sensors are capable for earlier. Well, with the ACS 712 IC being able to detect both AC DC current, it can be used in a wider range of applications apart from electrical appliances. Be it Arduino, other microcontroller usages, or industrial commercial and communication, it can be found applicable. Motor speed control in motor control circuits, electrical load detection and management, switchboard power supplies, or protection for overcurrent. What are the alternatives? Groove 10 ampere DC current sensor ACS 725 is the alternative. With some users of the ACS is not recommended as your current sensor option due to its low sensitivity and bad linearity. We have come forth to provide an alternative recommendation, the Groove 10 ampere DC current sensor that based on ACS 725. When drawing comparison to the ACS 712, the Groove 10 ampere DC current sensor has the following performance advantages: higher bandwidth, higher sensitivity, groove interference is easy plug and play pairing with your Arduino and etc. AC DC current sensor ACS 70331. It is another alternative to that. If you are looking for a current sensor that supports both AC DC yet retaining performance advantages over the ACS 712, then we have ACS 70331. Its features include 1 mHz bandwidth response time less than 550 nanoseconds, low noise 8 mA at 1 mHz, 1.1 milliohm ceramic conductor resistance results in lower power loss, higher DCP-SSR enables the use with low accuracy power supplies or batteries, 3 to 4.5 volt operation. So current sensors, Arduino guide and hardware assemblies like Connect Groove 5 ampere DC-AC current sensor, and connect to the positive and negative poles of the circuit to be tested to the corresponding positive and negative poles of the screw terminal. Plug groove base shield into Arduino, connect Arduino to PC via USB cable. It should look something like this after completing the above steps. Software configuration and Arduino library is like that. Then we have this code of it. So yes, thank you. The fourth sensor that I have took is color sensor, and the introduction to that color sensor is that it is a complete color detector, includes a TOS TCS RO sensor chip and a 4 white LEDs. Can detect and measure a nearly limitless range of visible colors. Application includes test strips reading, sorting by color, ambient light sensing and calibration, and color matching, to name just a few. It has an array of photo detectors, each with either a red, green, or blue filter or no filter. The filters of each color are distributed even throughout the array to eliminate location bias among the colors. Internal to the device is an oscillator which provides a square wave output whose frequency is proportional to the intensity of the chosen color. Specification are single supply operation, 2.7 volt to 5.5 volt, high resolution conversion of light intensity to frequency, programmable color, and full scale output frequency. Power down feature communicates directly to microcontroller. SOS1 output frequency scaling selection inputs. S2 and S3 are photodiode types selection inputs. Output pin is output frequency. OE pin is output frequency enable pin. Active low can be impending when using spot LED lamp light supplement control. Size is 28.4 cross 28.4 millimeter. Pin out. It looks like this. Description is given like power supply ground. All voltage are reference to ground. Enable OE is enable for 4 active low output frequency. SOS1 output frequency inputs. Photodiode selection input supply voltage VDD. So connection diagram is like this from color sensor to Arduino, and VCC is 5 volt, S0 is directly related to D3, S2 to D5, output D2 ground to ground, S1 to D4, and S3 to D6. Output frequency scaling. S0 S1 to when choose a color, it can allow only one particular color to get through and prevent other color. For example, when choose the red filter, only LED incident light can get through, blue and green will be prevented. So we can get the red light intensity. Similarly, when choose other filters, we can get blue or green. So photodiode type is S2 and S3 is given LL, LH, low, high, high, low, and high, high. Red, blue, clear, no filter, green. This is the simple code of this color sensor that we use with Arduino, and after that this is the result that we get. And thank you. Hello again, sir. The fifth sensor that I took is voltage sensor. What is voltage sensor? Voltage sensor is a sensor that used to calculate and monitor the amount of voltage in an object. It can be determined the AC voltage or DC voltage level. Input of this sensor is voltage, and the output is the switch's analog voltage signal, current signal, or an audible signal. There are different types of sensors. The two main types of voltage sensors are available are capacitive type voltage sensor and a resistive type voltage sensor. What is capacitive type voltage sensor? We know that a capacitor comprises of two conductors or two plates. Between these two plates, a known conductor is kept. The field among the plates will create a complete AC circuit without any hardware connection. This is how a capacitor works. Next, we can discuss the voltage division in two capacitors which are in series. In the case of capacitors, capacitance and impedance are always inversely proportional. The relation between voltage and capacitance is given like this: Q charge and C capacitance, X is capacitor reactance, and frequency. From above two relations, we can clearly state that the highest voltage will accumulate across the smallest capacitor. The capacitor voltage sensor works based on this simple principle. The sensor strip is the smallest capacitor coupled to the live voltage, thus the whole voltage will develop across the sensing circuit, which can detect voltage, and the light or buzzer indicated is turned on. Resistive voltage sensor. Two ways exist to convert the resistance of the sensing element to the voltage. The first one is the simplest method, which is to provide a voltage to the resistor divider circuit comprised of a sensor and a reference resistor which is represented below. The voltage developed across the reference resistor of sensor is buffered and then given to amplifier. The sensor's output voltage can be expressed as this circuit's drawback is that the amplifier presents will amplify the whole voltage developed across the sensor. It is better to amplify only the voltage change due to the change in the sensor's resistance. Then we have gain A is gain of instrument amplifier and sigma is change in the resistance of the sensor. Advantages of voltage sensor over conventional measuring techniques. The advantage of voltage sensor includes small in weight and size, personal safety is high, the degree of accuracy is very high, non-saturable, wide dynamic range and eco-friendly. Can combine the voltage and current measurement into a single physical device with small and compact dimensions. Application of voltage sensor. The application of voltage sensor include following: power failure detection, load sensing, safety switching, temperature control, power demand control, and fault detection. Voltage sensors are included in many of the best Arduino starter kits as they are very useful in many electronic projects. So, thank you. Hello again, sir. The sixth sensor that I will be using is ultrasonic sensor. It is used to measure the ultrasonic distance. So the configuration pinout of ultrasonic sensors are like this: VCC, trigger, echo, and ground. Then we have its sensor features. Operating voltage is 5 volt. Theoretical measurement distance is 2 centimeter to 450 centimeter. Practical measurement is 2 centimeter to 80 centimeter. Accuracy is 3 millimeter. Measuring angle covered is less than 15 degree. Operating current is less than 15 milliampere and operating frequency is 40 Hz. Equivalent distance measuring sensor, US transmitter receiver pair, IR sensor module, IR sensor pair, and IR analog distance sensor are also its names. So ultrasonic sensors working. It is a 4-pin module whose pin names are VCC, trigger, echo, and ground respectively. This sensor is a very powerful sensor used in many applications where measuring distance or sensing objects are required. The module has two eye-like project in the front which forms an ultrasonic transmitter and receiver. The sensor works with the simple high school formula that distance is equal to speed into time. The ultrasonic transmitter transmits an ultrasonic wave. This wave travels in air and when it gets objected by any material, it gets reflected back towards the sensor. This reflected wave is observed by the ultrasonic receiver module. The distance using the above formula, we should know the speed and time. Since we are using the ultrasonic wave, we know the universal speed of US wave at room condition, which is 330 meter per second. Now simply calculate the distance using a microcontroller or microprocessor. How to use ultrasonic sensor? It is a sensor is commonly used with both microcontroller and microprocessor platforms like Arduino, ARM, and PIC, Raspberry Pi, etc. The following guide is usually universally since it has to be followed irrespective of the type of computational device used. Power sensor using a regulated 5 volt VCC and ground pins. Current consumed by sensor is 15 milliampere and hence can be directly powered by an on-board 5 volt pin. The trigger and echo pins are both input-output pins, hence they are connected to input-output microcontroller. To start the measurement, trigger pin has to be made higher for 10 US and then turned off. Once the wave is returned after it getting reflected by an object, the echo pin goes high for a particular amount of time, which will be equal to the time taken for the wave to return back to the sensor. Amount of time during which the echo stays high is measured by the MPU as it gives the information about the time taken for the wave to return back. Using this information, the distance is measured as explained above. Application. It is used to avoid and deter obstacles with robots like bike robot, obstacle avoider, robot, path finding robot, etc. Used to measure the distance within a wide range for 2 cm to 400 cm. Can be used to map the objects surrounding the sensor by rotating. Depth of certain places like wells, pits, etc. can be measured since the waves can penetrate through water. So, thank you.